Welcome back into another video where we are going to discuss a new section now, having done something about the perpendicular lines. So you have seen what we've done there and the expected type of questions that you're going to meet during exams. Now, issue about perpendicular lines. So the discussion here will remain the same as we have done with the parallel lines. So issue remain here on the Cartesian plane, where we have the y and x axis intersecting at one point, like the point of origin. Right, this one here, this is y-axis, this is x-axis. I'll always draw this one because we are discussing issue about the coordinates. It's coordinate geometry. So whatever we have lines in the Cartesian plane. Our scale can be developed here. It depends the type of scale you can use. 2 centimeters representing 1 unit or 2 centimeters representing 4 units. So here I'll go by 2 centimeters 1 unit, 2, 3, 4, 1, 2, 3, 4, -1 here, -1, -2. Issue about now perpendicular lines. First thing is to determine if two lines are perpendicular, as we have been doing to determine if two lines are parallel, have the same gradient. Now, suppose I have one line that is drawn like that, line connecting A and B. There there's X, Y, here there's also X, Y. We know for sure that the points for any line here are defined by 2 coordinates, X and Y. Then now, it might happen that there'll be another line that we're going to draw in there, and this line happens to pass with the other at right angle, or they cross at right angle, line AB, and here I've got another line that crosses with another one at right angle, like this one. This line is TQ. Right. Also, it has got the X and Y coordinates, and this point also have got X and Y coordinates. Right, we have got such situations, and that is normal. You can draw several lines, but the lines can be crossing at right angle. In this situation, we say that line AB is perpendicular to line what? DQ. Right, now, what is it that we need to know about this? Our target here is simply, there again, to determine if lines are perpendicular to each other. What is the indicator that we can use to show that lines are perpendicular? As we have done there, in the previous video, we were determining that lines are parallel. The indicator was the gradient. Equal gradient, it means lines are parallel. So here, one indicator, of course, you can notice if the lines are intersecting around right angle. But necessarily here will not be there going to show that the lines are intersecting around right angle. It's just an issue of drawing the several lines on the Cartesian plane. For you to tell that these lines are intersecting at the right angle, they are parallel. So they are perpendicular. How do we notice without the indicator of right angles? Right, so here I'll also be quick because you are not here visibly. I'll just be here giving some kind of directions, and I expect you to do some kind of checkup somewhere. So what I need you to do is you try to draw 2 lines and notice that these lines are intersecting at right angles. Right, then thereafter I'll ask you to work out the gradient of one line, gradient 1, and then find the other gradient. That is now gradient 2. Find the gradient of the other line. So it's more like try to have 2 lines which are perpendicular to each other. Let's say this line is perpendicular to that line. What you're going to notice is that if you are going to calculate the gradient of one line and the other line for the 2 lines which are parallel, which are perpendicular to each other, you try to find the product of which. Like the product of gradient 1, meaning to say gradient 1 should multiply by gradient 2. Issues about 2 lines which are perpendicular to each other. I have got the gradient of one line being this one here, G1, and the other one is G2. You are going to notice that when you multiply, you're always going to notice that the result here should be always be -1. Meaning to say, if lines are perpendicular to each other, the product of their gradient is always a -1. If the product does not turn out to be -1, then please just know for sure that the gradient, that the lines are not what? Perpendicular to each other. Right, we are fast because of time and also the space on the board here. Please try to do this activity. Notice that the two lines are perpendicular and you try to calculate the gradient. That should always be what? -1. Right. Now, what is it that we should do? Let us now capitalize on this one. Right? And identify the pair of lines which are perpendicular to each other. Right. So in the normal circumstances, formally, for us to obtain a -1 to come out, that's the product of two gradients being -1, what we should expect always, it will be an issue of nature of the two gradients. Line 1, if line 1 has a gradient as m, then you should expect that, say, if we're going to work out the gradient of the other line, that is 2, the gradient of which should always be -1 over m. More like the other one will always be a fraction. That's how it will be. And when now you try to work out the product of the gradient of line 1 and the gradient of the line 2, that's the format. It will be equal to m multiplied by -1 over m. So it will be like m cancels with another m. Then multiplied by -1, the answer is -1. So that is the value of the product of the two gradients. So for what I've indicated here, that G gradient 1 times gradient 2 is -1, the story will be like the gradient of one line, if it's in that form, then the other one should be more like a fraction but a negative. But if one line then from this case is maybe -m, then expect the other line to have a gradient which is a negative fraction. So it's just like the m now comes as the denominator. That's it. So let us look at these two examples. Just two are enough. You cannot have 100 examples here. That is your task. Work out several problems and be able to master what we are doing in here. What examples do we have? Let's have these ones. Right. To make it best, I'll just copy the equations as such. Number 1, we are having a first pair of the equation. This is 2y plus 3x is 2, and 12y minus 8x is 24. And this other one, we have that's y plus x3, and we have got y is equal to x plus 4. So question is just like are the two equations perpendicular to each other? More like, is this line and this line perpendicular to each other? Secondly, is this line and this line perpendicular to each other? Right. So you as the student, you don't have to worry about that. The condition remains the same. If I multiply the gradient of this equation, that equation, the value is -1, then it's okay. Right. So let's try to work out on that one. Number 1, we have got the first equation as 2y plus 3x is equal to 2. So in that case, in that format, we cannot have the gradient until we make y the subject. So here I am, I'll have my 2y is equal to, this comes there, negative 3x then plus 2. I divide both sides by 2. Here I divide by 2, and then divide by 2. I'll have my gradient as negative 3 over 2, because that is the coefficient of x, right? So here my gradient is equal to negative 3 over 2, gradient of the first line. Make y the subject, so you have to divide all the term there by the coefficient of y, which is a 2. So you have your gradient as negative 3 over 2. Okay, let's put this one aside and try to work out the gradient of the other line. This other line is defined by 12y minus 8x is equal to 24. So what we have here, we take this one to the right hand side. So we have here 12y is equal to 80x plus 24. So what do we have now? Here we need also to make y the subject. So what we have here, it'd be like 12y is equal to 8x plus 24. We divide both sides by 12, also all terms by 12. Here divide by 12, divide by 12. So you have 12 and 12 is 1, and y comes in as the common factor for this, and this is 4. 4 here is a 2, 4 here is a 3. X plus a 2. Right. So if we were to find the gradient in this case, our gradient here is what? I see the gradient here comes in as 2 over 3, like that. Now, let me now try to find the product of the two gradients. This one and this. What is this that I'm going to yield out of that? So here I'll have product is equal to, this gradient here is 2 over 3 multiplied by negative 3 over 2. So you see here 2 here 1, 2 here 1. 3 here 1, negative 1, 3 here 1. And the story here gives us a negative 1. So this tells us something. The moment gradient is negative 1, then we can deduce that the two lines are perpendicular to each other. Right. So I'll leave the second example for you, just like an exercise. So do as I've just done in the first example. Try to calculate the gradients of the two lines and then try to come up with the product of those two gradients. And if the value comes as negative 1, then those two equations are really perpendicular to each other. But if the product is not negative 1, then deduce that the lines are not perpendicular to each other. Right? Let us have now the last example in this section, where now we have to calculate the equation of the line that is perpendicular to the other one. Right. How do you calculate the equation of the line that is perpendicular to the other? After knowing how to determine lines which are perpendicular to each other. All right, just a simple example. Of course, these things are straightforward. They are not all that complicated. So like here, we say, can you find the equation? They say find the equation of a line that is perpendicular to another that is a line whose equation is 2y plus 3x equal to 1 and passes through the point, which point is this? Point minus 3, comma 1. Right. So that's it. Find the equation of a line perpendicular to another line. This line has an equation just like 2y plus 3x is equal to 1. And they say this line, it passes through the point negative 3, 1. So what is here is more like you have got a situation. We have two lines here, like this one, this line. Let me just draw it. This is the line and another line goes like that. And we are told that the two lines are perpendicular to each other. And the equation of one line here, let's take maybe this line here, is 2y plus 3x is equal to 1. But now, here is another line. The equation is not known. So you can represent it by y is equal to mx plus c. You know that is the general form. But this line is passing through the point minus 3, comma 1. That's what we are told there. So the question is interpreted this way. Right. So what is the equation of this line? So you now as a student, since we have started working out each above the equation of the straight line segment, the instructions remain the same. You don't just come up with the general form and try to check which are the variables that you're supposed to calculate. Then once you've found them, just substitute, then you have got the equation of that line. So like here, you can say, let the line be defined by y is equal to mx plus c. So what is needed? Just find the gradient and find the what? The value of a c. Right. So to calculate the value of the gradient, which is m in this case, you need at least to refer the information of which to the equation of the line, which is already given and is perpendicular to that line. So in this case, the gradient of this one has to be referred to this equation here, 2y plus 3x is equal to 1. So once you know the gradient of this line, at least try to use some kind of mathematical application to determine the gradient of this other line. If the gradient of this line is known, what do you think would be the gradient of this other line that is perpendicular to that? So by the condition we have had, so the product of the gradient should be negative 1. I think you'll be in the position to be able to determine if the gradient of that one is known as a, then it means the gradient of the other one should be negative 1 over a, thing like that. So let us find the gradient in this case for this line here. So here, what is there? We need to make y the subject to obtain the gradient of that one first. So here we have 2y plus 3x is 1. Let's transfer this one to this side. So I've got 2y is equal to negative 3x plus 1. That's it. To make y the subject, here I've got y is equal to negative 3 over 2x plus 1. So gradient here is negative 3 over 2. That's the gradient of this line. So if the gradient of this line is negative 3 over 2, it means the gradient of this line we're looking for should be something that you feel you can be multiplied by this one to give you negative 1. So in this case, you try the best to say, if this gradient is negative 3 over 2, then possibly the other values that can multiply by this in order to get negative 1, possibly you can play the games with these two values. A denominator, you try to put it as what? A numerator, and the numerator becomes like a denominator. So this gradient already have a negative, then the other value shouldn't have what? A negative. So in this case, I'll capitalize on the negative 3 over 2 to come up with the gradient of this line. So it'd be like, if this negative 3 over 2, then the other line to be multiplied by that should be 2 over 3. So that when I say 2 here, 1, 2 here, 1, and 3 here, 1, 3 here, -1, then that should be -1. So it means, obviously, if the gradient of this line is -2 over 3, it means the gradient of this other line possibly should be more like the reciprocal of that one, which is just like 2 over 3. Right, so that's the gradient of this line. Y-intercept, capitalize on that. Use that point through which that line passes. You do just have to substitute as I've done earlier, check in the previous videos, right? So which means, by what we have already discussed, to find where this line intersect the y-axis, you're going to have your equation, form of the equation y is equal to mx plus c, such that wherever there's y, we are going to write a 1. So here there should be 1. Where there's m, we're going to write 2 over 3 multiplied by a x, which is the -3, then plus a c. So what we have here, 3 here, 1, 3 here, -1, and I've got a 1 is equal to -2 plus c. So this comes here, it'd be 1 plus 2 is equal to c. Right, so which means in this case, our c's value should be equal to what? A 3. So that is the y-intercept. As such, to make some conclusions on this, then we're going to conclude in this way to say the equation of the line perpendicular to 2y plus 3x is equal to 1 is this one. Equation in this case will be defined by the following. Equation will be y is equal to mx plus c. In this case, your y remains the y, and your m is 2 over 3 times x, you get x, then plus a 3. So that's the equation of the line perpendicular to the other line. Right, so that's it that we have had in this section. So what we do, we're going to stop here for this section. We are done. We have known how to determine that the lines are perpendicular to each other, and we have known how to calculate up the what of the gradient, sorry, not the gradient, but now calculate the equation of the line whose equation is not known, but we know that it passes through one of the points being it perpendicular to the other line. That's it about it. Right, so the last section that we are going to have, and it will wipe up everything, or covering up the topic, is an issue about the midpoint of straight lines. Right, issue about now, midpoint of the straight line. So it means a line can have a midpoint. You see how we are studying the line? Parallel, perpendicular. Now let's also discuss the issue about the midpoint. So here, I won't even take much of your time, since this is the final part of our discussion on this topic. What I have here, I'll also just explain it to you. Right. So, midpoint of a line segment. Right. And if it's like if I can have the Cartesian plane like this one, that is my Cartesian plane, xy, and have my scale here, 1, 2, 3, 4, 5. This is the 0. -1, 1, 2, 3, 4. Here, -1, -2. And I have the first point here is this one. That is point A. And this point defined by x is 1, y is 2, right, is joining another point at this position here. X is 5, y is 4. Let's have another point here. B, x is 5, y is 4. Right, 2 points on the Cartesian plane. And now I decide to join the 2 points. In so doing, I'll end up having a straight line segment, which is this one, line AB. So I've done a lot about this line, so many things we have learned about this. The line can be perpendicular to the other, the line can be parallel to the other one, the line has got a gradient. The line can have a distance. How long is it from there? Now, the issue about the midpoint, issue about the mid part of the line. Right, so here is that. You'll be asked this type of question, find the midpoint of line AB. So to you as a student, when you ask such questions, how to respond to it matters most. It's not just a matter of coming here, draw the line and say, here's the midpoint. No. You answer these questions by giving us the value of the coordinates. The moment you talk about a point being the midpoint, then that point should always have what? Value of x and y. So just like this line is made up of several points, there's one point that is right at the middle, and maybe just approximately here you can tell that the midpoint of this line should be somewhere here. If you can use a ruler to measure that the distance from here up that, what is that? If it is 10, then you can know that the mid part of this line is the position where we have got a 5. So suppose it is here, then you'll be able to tell that, the midpoint of this line somewhere here. And the question comes and find the midpoint of this line. So what we want from you, just give us the coordinates of x and the coordinates of y. And this one, position, what is x, what is y? That's all. So each time I'm talking about the midpoints here, please try to take into consideration that here what we're looking at are the coordinates for x and y that determine the middle part of that line. So now let's discuss how can we find the coordinates of that part. Right. In the normal circumstances, to work out the mid part of that line, you'd find that you can be able at least to determine the distances that are there in terms of change along the x coordinates and along the y coordinates. Like say for example, if this is my point, starting point A, along the x-axis, I know for sure this position here is as good as being at 1, x here is 1. The moment I'm here, I'll be able to recognize that here, x is what? X is 5. Right. So if I'm to calculate how long is it from here up that along the x-axis, it's as good as when I'm here, it's as good as I'm here, and when I'm there, it's as good as I'm here. So it means from here up that is as good as from here up that along the x-axis. How many units do you have? You find that I've got 1, 2, 3, 4. Yes, it's 5, but here I've studied at 1, I've not studied at 0. So it comes the units we talk of, we're starting from a 1, we go here 1, then 2, 3, 4. So it means the distance from here up to that is a 4. Right. So if I'm to determine the middle part from here up that, then I'll talk of 1, then a 2. If I start from here, it is 1, then a 2. So it means the mid part of this one, of this line, it is here. If I can take a line, I'll go up like this one and come at this position here. And there, the value of x here is just what? A 3. Right. You can have this. So 1, 2, 3, 4. The mid part of the 4 units is always a 3 according to this case. We have studied at 1, 1, 2, 3, 4. So 4 units, the mid part is here. And again, if I go up, I am here is as good as I am at 2. At A, the value of y here is a 2. So it's just like on the y-axis, I'm at 2. The moment I'm at B is as good as if I go to the y-axis, I will know that one is the position 4. X there is 4. So the y there is 4. So if I'm to find out how long it is from A to B along the y-axis, it's as good as I am from 2 up to 4. So if I'm to count how many units are there from here up that, it'll be like 1, then 2. So the middle part of 1, 2, it is a 3 here. This is the middle part. You can see here 1, 2 units, so the middle part is there. So if I'm to go straight by that line going something like this, then I will know that the middle part is where the two lines meet, one from the x-axis, another one from the y-axis. So this position, it tells us the value of x there is 3, and the value of y there is also what? A 3. So it means we're talking of the midpoint of this line is just the x is 3, y is 3. So you can determine this one by using the number of units covered along the x and y axis. You look at the middle part. How many units are there along the y axis? From position A to position B. Oh, 2 units. The middle part is what? The middle part is just like 1. So you can just count from the starting point, we're starting at the 2. So you count 1 and then you fall at the 3. So that is the 3. This is the 3 represented by that y coordinate. And this one, you count from here up to B along the x-axis. It's as good as from here up to that. So if I count is 1, 2, 3, 4. So the middle part of the 4 is just like a 2. I count 2 units, 1, 2, and the 4 at what? At the 3. The coordinate at the 2 here is what? A 3. So this is the midpoint of the line. X is 3, y is a 3. Right. So now we may not trust this method of counting the units. So as mathematicians, let us come up with a formula that can help us to come up with the midpoint of the line. Here we know the midpoint is 3, 3. So the formula here that we're going to compose is more like a question which has to be answered in such a way as what is the other way that can help us to obtain the value 3 and a 3. So here, if you can focus on this line, connecting A at 1, 2 and connecting B at 5, 4, you're going to realize that that midpoint has something to do with the x and the y coordinates. Right, what is it that we can have here? Let's first of all begin with the first 3 here. A 3 as the x coordinate on the midpoint. It found that this 3 is as good as considering the what? X coordinates for point A and point B. This is the part of x, 1, and here the part of x, which is just a 5. So if you try to sum up 5 plus a 1 and divide by 2, you're going to appreciate that the value of x there becomes a 3. And here again, to work out the value of the y coordinate, you can just sum up the value of y, another value of y, which is 4 plus a 2. Then that one should be halved, divided by 2. So what I have here is more like a summation of 5 and 1 giving me a 6. I questioned by a 2, and here I also get a 6, divided by 2, and that I've got 3, 3. Right, you see that? So which means in this case, we can just think of substituting. What is this 5? What is that 1? What is this 4? What is that 1? A 2. So in here, you'd find that 5 and 1 are x coordinates. So you can define them as this one is x1, this one is x2. So what we're doing here when you say 5 plus 1 is as good as saying x2 that was as good as having x. So the brass choke is hard and the ball is slippery. So x2 plus x1 divided by 2. And here we talk of what? This is y, this is y. So we talk of y2 plus y1, then divide by 2. So that is the formula for the midpoint of a line. Midpoint of this line, AB, is determined by x1 plus x2 divided by 2. And for the y coordinate, we talk of y1 plus y2. So this is y1 plus y2. The summation there, if you interchange up the value, that doesn't matter. So x2 plus x1, you get a 6. y2 plus y1, you get a 6. You divide by 2, you divide by 2, you get a 3, you get a 3. Right, so every time you are asked to calculate the midpoint of a line, please, this is a formula. x2 plus x1 divided by 2, y2 plus y1 divided by 2, and they give you the coordinates, and which comes like 3, 3. Right, so what I'll do here, I'll not, there's no need for I at least to give an example that we need to have to use that formula. This example is just a self-explanatory. But when you're in practice, can you just have this one? only 2 problems where you need just to determine the following. Right, there's a line joining, that is the line here. I'll draw the line itself. This line, KH, as your assignment, is connecting K at talk of -1, 0, is K is joined to H. H is found at 4, 7. So what you're going to do with that line, you're going at least to summarize everything. 1, work up the gradient of this line so that you have to appreciate that the line has a lot of issues around it. 2, find the equation of that line. And then what you should do there again, I would need you also to work out the distance. Distance between K and H. The same line, you need to find the what? Midpoint. Right, so I want you to calculate the gradient of this line, KH. Secondly, you have to find the equation of this straight line, and then find the distance between K and H, and finally find the midpoint of that line. Another moment in time, I also need you maybe to wake up the line that can be parallel to that and line perpendicular to that once this other line is known to pass through other points within it. But all in all, this is the end of this topic. Thank you very much for being together. We have had a wonderful time, and I hope you have learned much about this. Thank you very much.